First, reflection. A reflection is a flip over a line of reflection. And I really want you to focus on that word flip. Okay, and you guys did this without me the other day on the video, but it seemed like everyone was fine. You guys did this before, correct? Okay, so original figure triangle ABC. A is at -1, 5. B is at -4, 2. C is at -3, 5. Okay. So there's my original. And I want to make sure that we label this as the x-axis and this as the y-axis, because this very specifically says reflect across the x-axis. Okay, so what I'm going to do when I reflect across the x-axis, so you can use tracing paper like we did in the video for number 1 through 6, that's totally fine. But a reflection has to be the same distance away. So what I'm going to do is I'm going to count the boxes to my line of reflection and then count the boxes to the other side. So 1, 2, 3, 4, 5. So 5 boxes to the line of reflection. 1, 2, 3, 4, 5. And this point will be A prime. Now I go to C. 1, 2, 3, 4, 5, away from the line of reflection. 1, 2, 3, 4, 5. This becomes the dot C prime. And then B is 1, 2 dots away from the line of reflection. So I go 1, 2 dots on the other side. And this becomes B prime. Now we're going to state what coordinates they are. So A prime is -1, -5. B prime is -4, -2. And C prime is -3, -5. Okay, so here's my question. Can anyone tell a pattern with the coordinates for when you reflect across the x-axis? What does a reflect across the x-axis do to the coordinates? Yeah. It changes the sign of the y coordinates. So now in your math brain, what do you think a reflection across the y-axis would do? We're not going to do one, but what do you think it would do to the coordinates? Changes the sign of an X. Perfect. Look at you guys picking up math patterns. It's good. Okay, any questions about reflections before we move on? You sure you're good? Okay. Now we're going to go to rotation, which is what we're actually going to work on today after these notes. So go ahead and set up the rotation section. And I'm definitely going to use tracing paper for rotation. So get that handy if you want to. Okay. What is a rotation? A rotation is a turn around a fixed point. And usually in our class, pretty much always in our class, it's going to be the origin or 0, 0. But I do want to draw little pictures here. So we need to talk about clockwise and counterclockwise because you guys probably don't even know we don't have regular clocks anymore. So clockwise is going this way. And counterclockwise is going that way. Okay, so now I'm going to graph that same triangle I had in the first example. Negative 1, 5 is A. B is at negative 4, 2. C is at negative 3, 5. Okay, and then because this is a rotation, I'm going to use the tracing paper. I'm going to find a corner of the tracing paper to use. And I'm going to trace the triangle. Okay, now I'm going to use the patented Mr. Jones method of rotations. So Mr. Jones told me that it's really helpful if you put a little plus sign on the origin. So trace your figure, put a little plus sign on the origin, and then stab your pencil into the middle of the plus sign. And he said every time the plus sign matches up, that's a 90-degree turn. You just have to figure out which direction. So this particular problem says clockwise. So we're going to go that way. Clockwise is that way. So stab your pencil into the middle of the plus sign and then rotate until the plus sign matches up one time. That's 90-degree rotation. So each time it matches up, it's 90 degrees. And then what you do is you peel up the corners and basically go underneath and make the dots. So there's a dot there. There's a dot there. There's a dot there. I have this really fun memory of having my goddaughter in my math 1 class years ago, and she always used tracing paper for all of the rotations and things. And she was home one night and couldn't find her little piece of tracing paper, so she went into her mom's cabinet and got one of those like pie liner things, like the wax paper that you like put on the bottom of a pie. And so every day she would come to class and like unfold it, and it would make like a bunch of noise. It was like so funny. Anyway, I thought it was hilarious. Okay, now there's another technique that you can use that I'm wondering if a lot of you guys like. If you sort of weaned yourself off of using tracing paper because you don't want to use it, I've noticed a lot of people just turning their notebooks and then making their new picture look like this. Does that make sense? So turning their notebook and then going back to the original and making the picture look like it did when it was turned. Um, there are other people who can just completely visualize it without tracing paper, which is totally fine too. Oh no, this is terrible. I did it in blue. It was supposed to be in red. Oh well, it's fine. It's totally okay. It's not a problem. Okay. So A prime new coordinate is 5, 1. B prime is 2, 4. And C prime is 5, 3. Okay. Now this is fun. Anybody be able to pick up the pattern of what's happening with the coordinates from the original to the 90-degree clockwise? Yeah, Joaquin? Switch places and something else. Yeah, okay, it's not, you're right, but they switched places and then the new one in the front switched sign. So they switched spots and whatever became the X also switched sign, which is kind of fun. Okay, this is so sad. So sad. Can I fix this in any way, shape, or form without whiting out the whole thing? No? You're telling me no. I hear you saying no. I hear you saying, Mrs. Talbot, get on with life. It's okay. Really fine. We don't care that much if it's not red. But I care. Okay, last one. And the easiest one. Easiest one for last. Okay, so I just wrote the translation definition. It's a slide. Um, I have a question, an eighth grade question. Did you say flip, turn, and slide, or did you say reflection, rotation, and translation? Okay, but you know flip, turn, slide? Did you ever say those? Never? Okay, they skipped right straight to the real vocab. Nice. Okay, so let me draw this triangle for the last time. Red pen, Mrs. Talbot. Yeah, 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 I got it now. Okay, down four, right six. I'm gonna start with V, the bottom one. I'm gonna go down four, right six, and make my new B. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. Anybody know what happened to the coordinates in this one? Yeah. Perfect. All of the x's, we added 6. All of the y's, we subtracted 4. Okay. You guys are done with your notebook after you're done with this? Finish it up if you're not done. And then grab your packet. Okay, I need you guys to find, when you're ready, find warm-ups 5, 7, and 11. You guys good over there? You sure? No? Okay, you sure? Good. All right. 5, 7, and 11. The reason we're doing 3 is because number 5 is super short. Okay. Number 5. Y equals -5. What kind of a line is this? True, but I'm looking for horizontal. Okay, so what you do is you go on the y-axis to -5, and then you just draw a horizontal line through. And that's really it. That's why I figured we could do 3 warm-ups, because that one was just that. Okay, number 7. Write the slope-intercept form of the equation of the line through the given points. First thing we're going to do is find the slope. Y2 minus y1 over x2 minus x1. So I have -4 over 1, which is -4. Do you guys see anything special about this particular problem with B? What is the correct vocabulary word for B? Y-intercept. What is the y-intercept in this problem? -1. They already gave it to you. They don't usually give it to you, but they did in this one. They did not in this one, but they did in this one. So that means final answer, y equals -4, x minus 1. We don't have to do all the work because one of the points just happened to be the y-intercept. Hooray. Now, let's just pretend you didn't see that and you went through all the work that we normally do, you would still get the same answer in the end. Okay, last one, number 11. Scooch down to number 11. And this is what we did yesterday. And we need to be really careful about this because I feel like it's kind of hard. Okay, first thing I want you to notice is that this problem says parallel. So you're going to put an X and a Y on the point it gives you. And then you're going to put an M on the slope of the line it gives you. So X, Y, M. And this particular problem says parallel. So I'm going to write my symbol for parallel M. If you were not here yesterday, this probably sounds like a foreign language. Okay, what is a slope parallel to a line with a slope of -4? -4. Parallel lines have equal slopes. They just happen to be like right next to each other. Okay, now I have a question for you. Can you picture these two lines? Do you think they would be parallel to each other? Yeah, one's just above the other one. Okay, now last thing for the day, I need you to find the resource page that has number 38 on it. So we're done with 2 out of 3 things. Find the page with number 38. Okay, and now we're going to work on rotations. Okay, so grab your tracing paper in a different corner. Start tracing the whatever this is. What is this? And then where this circle is, this little dot right here, I'm going to put my plus sign there. Okay, so I traced the, what is this, a truck? Is it a spaceship? Is it a duck? You don't see the duck? It's a snake? What is it? It's definitely a snake now. Okay, anyway. Oh no, I had too much fun. Okay, so this particular problem says go 180 degrees this way. So this is clockwise. So stab your pencil into where the little dot was, and you're going to do 2 turns because each turn is 90 degrees. So this counts as one turn. This counts as two turns. Okay, and then peel it up and make the shape on the other side. Okay. Okay, so for the next one, it says go 180 degrees again, but rotate the opposite way. But you're going to notice something. What are you going to notice? Yeah, it's going to end up in the same exact spot because 180 degrees is halfway around. So it's just going halfway to the left or halfway to the right. Still ends up halfway. Okay, once you got those two guys done, find a different spot in your tracing paper for this kite looking guy. And the dot right next to him. Are they not by the front door? Hmm. Okay. All right, so in this problem, it says go clockwise, which is this way. And 90 degrees is one turn. Which apparently I can't do properly. Not supposed to be overlapping, I don't think. What? Why did it do that? It's supposed to be like that. Sorry. What were you gonna say? No. Oh. Did I do a terrible job of tracing this? What? It's supposed to be like here, isn't it? Okay. I'm going too far, you say? Okay. Gonna have to do the Mr. Jones patented method. Ha! Mr. Jones patented method. Oh, this is distracting me. I see. Thank goodness you and Payson are here. What? What's wrong? Other than the other things. All right. I'll be here. Okay. Going the opposite way. Man, Mr. Jones' patented method's way better. You should see him. If you see him at Rayleigh's, you should say, Mrs. Talbot really loves your patented rotation turning method. Does Mr. Modaber use it too? We both learned it from him. Now, there's a lot of interesting things here, but what do you notice about F, G, and H? Yes. Yeah, you don't really, there's nothing to do there. 360 just goes all the way around again. 180 is just going to flip this upside down, which is the same thing, and 90 is going to make this square right back on itself. So really the only one we have to do is this guy, but this guy's going to end up looking like one of the other ones. So let's go here. I'm going to flip my arrow. And 270 is 3 turns. 1, 2, 3. And then what do you notice? It's the same thing as, yeah, going the opposite way, 90. That was the most fun I'm gonna have all day. Okay. What is the homework? 45 to 50? Okay. Except for that I don't see you guys tomorrow, huh? Some of you.